This is part 2 of section 7.2. We're still trying to find the least common denominator, and here we have 3 potential denominators. We need to factor each one as much as possible. Well, r plus s does not factor, so I put it in parentheses. R minus s does not factor, so I put it in parentheses. R squared minus s squared, this is a difference of squares, so it factors as r plus s, r minus s. Now for the LCD, we write down every base. I have an r plus s base. I have an r minus s base. Here I need an r plus s, I've got it. I need an r minus s, I've got it. The largest exponent that appears on an r plus s is a 1, so that's a 1 there, understood. And then r minus s, the same thing, the largest power is a 1. This is your LCD. Okay, so let's actually work some problems. We're going to do a subtraction here. My denominators are x minus 1, which does not factor, and x. My LCD, I have an x minus 1 base, and I have an x base. Neither of these is raised to an exponent other than 1, so this is my least common denominator. I want to rewrite this problem as something over x times x minus 1 minus something over x times x minus 1. Now what you want to ask yourself is, from this denominator to this denominator, what did I have to multiply it by? It's been multiplied by an x. If you multiply the bottom by an x, you need to multiply the top by an x as well. So this is x in the top here. Do the same thing from here to here. That x is there. I've been multiplied by an x minus 1. So if I multiply that by an x minus 1, I need to multiply this by an x minus 1. So up here, I have this. Now we have the same denominator, so we can subtract across the top. Because it is subtraction, I need to keep those parentheses. Okay, so to simplify, I need to distribute this understood negative 1 there. So I get x minus x plus 1 over x times x minus 1. X minus x, that goes away. You end up with 1 over x times x minus 1. Now we should check to see if this reduces any. Since it's a 1 in the numerator, it's not going to reduce. This is your answer. You want to make sure that your fraction bar covers everything. If something slips off to the side, you're really going to mess yourself up. Also, you do not ever want to write your fractions like this. Okay? It is too hard to tell whether this is 1 over x multiplying x minus 1, or if it's 1 over this whole thing. This is called a Schilling fraction. Don't do it. It causes major problems. And there are instructors at Lee College who will count your problems wrong if you write them like that. Okay, so let's try this one. We have 3 denominators. X minus 1 does not factor. X plus 1 does not factor. But x squared minus 1, this is a difference of squares, and it factors as x plus 1, x minus 1. Rather than rewriting the whole thing, I usually just factor underneath. So my LCD, I need an x minus 1. I need an x plus 1. I need an x plus 1, it's already listed. X minus 1 is already listed. The largest exponent that appears on an x minus 1 is a 1. Same thing for x plus 1. So this is your LCD. This third fraction is not going to need to change at all. So I'm going to rewrite these with x minus 1, x plus 1 in the bottom. Since that last denominator is exactly what I need, I just bring over the 4. Don't have to worry about changing anything. Okay. Now from here to here, I had the x minus 1 already. It's been multiplied by an x plus 1. So I need to take that 4x that's in the top and multiply it by an x plus 1. If you look at this fraction alone, you could reduce it and go back to here. So these are equivalent fractions. Now something similar happens right here. I had the x plus 1 already, so I need to take that 2 and I need to multiply it by an x minus 1. Okay, so let's look at what we have here. We have 4x times x plus 1 minus 2 times x minus 1 minus 4 all over x minus 1, x plus 1. Now we definitely want to distribute here and then here so we can simplify. That gives me 4x squared plus 4x minus 2x plus 2 minus 4 all over x minus 1, x plus 1. Combine like terms here. 4x squared, that's going to be plus 2x minus 2 over x minus 1, x plus 1. Okay, so we've done all the subtractions. Now we need to see if this reduces at all. So that means we need to factor this numerator. Well, I can factor a 2 out of the top, leaving 2x squared plus x minus 1 over x minus 1, x plus 1. Okay, so I need to see if I can factor this further. I do not have another GCF. I do not have perfect squares on the ends. So I'd be looking for two numbers that multiply to a negative 2 and add to a positive 1. So that's going to be 2 and negative 1. So that gives me 2x squared minus x plus 2x minus 1. And then add your groupings. And you can factor out an x here, leaving 2x minus 1. And then here you can factor out a 1, leaving 2x minus 1. So that means that this factors from right here. I still have the 2 on the outside. And this will factor as 2x minus 1, writing that down once, times x plus 1. And then recopy your denominator. And now if you look at this, you'll see that we can reduce the x plus 1s, and then nothing else cancels out. So your answer is 2 times 2x minus 1 over x minus 1. Now you can put the x minus 1 in parentheses if you want to, but it's not necessary. It is also not necessary for you to distribute through this top here.